Hello students. So let's continue with the problems. So the sixth question, a 1.5-meter tall boy is standing at some distance from a 30-meter tall building. Okay. The angle of elevation from his eyes to the top of the building increases from 30° to 60° as he walks towards the building. Find the distance that he walked towards the building. Okay. Let's say uh, let's say we have got a person, okay, whose height is 1.5 meter. Okay, let me draw it bit big. Okay, this is the person. Okay, so that is this height is the height of the person. Okay, let me take that as AB. Okay, so AB is the height of the person and it is 1.5 meter. Now this fellow AB is at some distance from a tower, from a building, 30-meter tall building. So let's take this to be the 30-meter tall building. So CD is the building. Okay. So height of the building is 30 meter. Let me write it this side. The height of the building is 30 meter. From here from top to the bottom, it is 30 meter. So AB is the boy and CD is the building. Okay. Now what is happening? So the top here is the eyes, isn't it? From the top of the from his eyes is watching the top of the building. Obviously, if he's watching something above, then it will be angle of elevation, isn't it? Now he's watching the top of the building. Now remember, the angle of elevation is always formed with horizontal line of sight. First, let's draw the horizontal line of sight. What is horizontal line of sight? Without lifting or bending his neck, when he's watching something, the line of sight will be something like this, isn't it? This will be his line of sight. Let's take this point to be E. Okay. So that will be the horizontal line of sight. So this is angle of elevation. This angle of elevation increases from 30° to 60°. Initially it is 30°. Now this person AB is walking towards the building. Okay. Let's say after some time, let's say is here. Okay. Let's denote it as A dash B dash. Okay. Now A dash B dash is the same person. Now after some time he is at the position here. Okay. Now sorry, again is watching the top of the building now. Okay, again is watching the top of the building. This will be A dash. Okay, now this angle will become 60°. As you can see, the angle is increased, isn't it? Earlier it was 30°. As he moved towards the building, the angle of elevation has changed. Now what we have to find is, earlier he was at the point B, now is at B dash. Now we have to find this distance. Okay, B dash is the distance that we have to find. This is the distance that he has walked, isn't it? That's what we have to find. Let's also join this. Okay, now very clearly the boy will be perpendicular to the ground, isn't it? Let me draw a straight line itself. The boy will obviously be perpendicular to the ground. So this will also be perpendicular, and obviously the building will be perpendicular to the ground, isn't it? And remember, the horizontal line of sight, that is AE and A dash E, will be parallel to the ground, isn't it? Therefore, here also you will have 90° itself. Very clearly. Okay. Here also you will have 90°, isn't it? Because this line is parallel to the ground, right? So obviously it will be 90°. Now, AB is the person and A dash B dash is the same person, isn't it? So AB is 1.5 in the sense. Then A dash B dash will also be 1.5, isn't it? Let me write it properly. 1.5 meters. That is A dash B dash. And AB is 1.5. Similarly, it is very obvious ED will also become 1.5 meter using the rectangle property. Okay, it will also be 1.5. Therefore, CE will become how much? 30 minus 1.5. So it becomes 28.5 meter. Very clearly, it will become 28.5 meter. Okay. Now, so these from the given data, we have drawn the figure. These are the things. Now, what we have to find is, we have to find the distance that is walked. Earlier, he was at point B. Let me color it Okay. Earlier he was at point B. Now is at B dash. Now we have to find this distance. Okay. Finding B dash is same as finding A dash, isn't it? Rectangle property. Opposite sides of rectangle are equal. So if you find A dash, it is also finding B dash, isn't it? Now, what you're going to do is, you should always check for right angle triangle. That's what you're going to do. Okay. And very clearly here also the angle is 90 degree. Okay. Because the horizontal line of sight is parallel to the ground. Obviously it will be 90 degree. Corresponding angles. Okay. Now, you're going to search for right angle triangle. See, what we have got here is, there are two right angle triangles. If you observe carefully, there are two right angle triangles. One is A dash C. Very clearly you will get to know A dash C, isn't it? That's a right angle triangle. Here you got A dash, here you got C, you got E, and this value is given as 90 degrees, and here you got 60 degrees, isn't it? And CE value is 28.5 meters, isn't it? Now, from the figure, the opposite to the given angle, 60 degrees is the given angle. Therefore, CE becomes the opposite side, and opposite to 90 degree becomes hypotenuse, and A dash E will become adjacent. Okay, this is one right angle triangle. We have also got another right angle triangle. Observe the figure carefully, you will get it. Which is the another right angle triangle? If you observe carefully, it is ACE. Is another right angle triangle. Remember, A dash C is a triangle, but it's not a right angle triangle. Okay. Now, as you can see, ACE, a big one, ACE. Okay. So here you got A, here you got C, here you got E. Obviously, this is 90 degrees, and this is 28.5 meter. Okay. Now here it is 30 degrees. Okay, opposite to the given angle. Again, C will become the opposite side. Opposite to E will become hypotenuse, and the remaining one is adjacent. Okay. Now observe this red color triangle and the green color triangle. Okay. Now we have got two right angle triangles, and what we need is A dash, which I have colored it in red color. Okay, here in the figure, as you can see, it is A dash is the thing that we need. Now what we can do is, see, we don't need AC, and A dash C value is not required. Okay, let's forget it. So what we are going to do is, initially we're going to use the bigger triangle, that is ACE, and we are going to find this entire length AE. Okay, so that is, we are going to use this green color triangle, and we are going to find the value of AE. That's it's very easy, we can find it. Similarly, in the red color triangle, we are going to find the value of A dash E. Then what will we do? We found AE, and we also found A dash E. What is required? A dash is required. Observe, the red color line is required. Okay, initially we found AE. In this green color, that is AE, if I subtract A dash E, what do we get? We get A dash, isn't it? So it's very simple. In the bigger triangle ACE, we are going to find AE. In the smaller triangle, that is red color triangle, we are going to find A dash E. Subtracted, we get A dash. A dash is actually equal to BB dash. That is the distance walked. Okay. So let's take the first triangle, that is in triangle ACE. Okay. Angle E is 90 degree, isn't it? You can observe the green color triangle. So what is the angle given? 30 degree. And we are trying to find AE value, isn't it? So opposite is given. We are trying to find the value of adjacent. So we are going to make use of tan. So tan 30 is opposite by adjacent. Opposite is CE. Adjacent is AE. Okay. So tan 30 is 1 over root 3. CE value is 28.5. AE value as it is. If you cross multiply, AE into 1 becomes AE. 25 into root 3 is 25. Sorry, 28.5 into root 3 is 28.5 root 3 meters. So you got the value of AE. So AE value, we have got it. Okay. In the next step, what we are going to do is, we are going to take the other triangle, that is triangle A dash CE. Okay. Again, E is 90 degree. You can observe the red color triangle. So the given angle is 60 degree. So we're going to use tan, because opposite is given. We have to find adjacent. So tan 60 is opposite by adjacent. Again, opposite is CE. Adjacent is A dash E. Now tan 60 is root 3. CE is 28.5. A dash E. A dash E is how much? A dash E, we have to find it, isn't it? So let's write it as it is. A dash E. Okay. In the next step, see, let's cross multiply. Root 3 into A dash E is root 3. A dash E is equal to 28.5. Therefore, A dash E will become 28.5 by root 3. Let's rationalize here itself. Okay. We should not have root 3 in the denominator. So let's rationalize here itself. Okay. So A dash E will become 28.5 into root 3 is 28.5 root 3. Root 3 into root 3 will become root 3 square, isn't it? Square and root gets cancelled. So directly I'll write it as 3. Or root 3 into root 3 is root 9. What is square root of 9? 3. So I have written it directly. 3 ones are 3. You can cancel it. 3 ones are 3. 3 nines are 27. 1 carry, it becomes 15. 3 fives are 15. Point as it is. Therefore, the value of AE is 9.5 root 3 meters. Sorry, A dash E. Okay, A dash E is 9.5 root 3. What we need is BB dash. So distance walked is actually equal to BB dash. Using the rectangle property, it is equal to AA dash. But AA dash can be found by subtracting AE and A dash E, isn't it? So AE is how much? 28.5 root 3. And A dash is 9.5 root 3. So if you simplify it, you get 19 root 3, isn't it? So 19 root 3 will be the answer. That is the distance walked by the boy, 19 root 3 meters. So very clearly we drew the figure first according to the data given. Then always we have to search for the right angle triangle. If you observe very clearly, there were two right angle triangles. One is the green color right angle triangle, and the other one is the red color triangle. And what we need is AA dash. Now if you observe, you can find AE and you can find A dash E. Subtracted, we get AA dash. That's what we have done. Okay. So let's get into the next question. Okay. From a point on the ground, the angle of elevation of the bottom and the top of a transmission tower fixed at the top of a 20-meter high building are 45 degree and 60 degree respectively. Find the height of the tower. Now we have to read this question carefully. From a point on the ground, let's say this is the point on the ground. I'm sorry, let me erase this. Let's say this is the point on the ground. Let's say it is A. A is the point on the ground. From this point, the angle of elevation, the angles of elevation of bottom and the top of a transmission tower fixed at the top of a building. So basically there is a building. Okay, let's say this is the building. Okay, let's say BC is the building. On top of the building, we have got a tower. And let's say DB is the tower. Okay, so DB is tower and BC is the building. Okay, DB is the tower and BC is the building. Now, if I join, AC is the ground. Okay, now what we are doing is from the point A, we are observing the top of the tower, which is an angle of elevation, isn't it? And we are also observing the bottom of the tower. Again, it's an angle of elevation because it's above, right? So in this case, we are observing the top of the tower as well as the bottom of the tower. In both the case, it is angle of elevation. Now, if is observing the bottom of the tower, obviously the smaller one will be 45 degrees. Very clearly, we can write it. And the bigger one will be 60 degrees, isn't it? The bigger angle is 60 degrees and the smaller angle will be 45 degrees. And remember, the building will be perpendicular to the ground, isn't it? The perpendicular to the ground. Okay. Now, again, the same task. What here we have to find is BB, the height of the tower. We have to find this length. Okay, let's take it as H. Let's take it as H. Okay, let me denote it by a different color. So let's say this is H, the height of the tower. Okay, let height of the tower be H, or let H be the height of the tower. Let H be the height of the tower. Okay. Now, again, what we have to observe is we have to observe a right angle triangle. Okay. Now, if you observe, we have got again two right angle triangle. Okay. The first right angle triangle is ABC. Let me draw it here. Okay. So A, B, C is a right angle. The right angle is at C. Okay. The angle will be, this is a smaller triangle, right? The angle is 45 degree. So opposite to it will become opposite side, and AB is the hypotenuse, and this is the adjacent. Okay. And they have given the height of the building, right? 20-meter high building. So BC value is given. So this is 20 meter. Okay. That is BC value is 20 meter. Okay. This is one right angle triangle. We have also got another right angle triangle. That is ADC, the bigger one. Okay. Let's take it in green color. Okay. ADC. Okay, this is A, and this is C, and this is D. In between here we have got B. Let's not worry about that. Now the angle of elevation is 60 degree, and here we have got 90 degree. Okay. And DC, we don't know the value of DC. Here in between you have got B. We know the value of BC. Okay. DB is H and BC is 30, isn't it? From, sorry, 20 it is. So 20. So this is 20, and we have got in between B, which is H. DB is H. Okay. Now we have got two right angle triangle. Then we are going to solve. Now, if you observe carefully, very interestingly, in both the triangles, a side is common. The common side is AC, isn't it? If you observe ABC triangle, you have got AC. ADC triangle, you got AC. So in both the triangles, you have got AC as the common side, isn't it? Now, whenever you have two right angle triangles, always try to find if there is any common side. If you have got a common side, then using tan theta, find that common side. That is, you're going to find the value of AC. Okay. In both the triangles, you're going to find the value of AC using tan. Okay. And you're going to equate it. That's what we are going to do. In both the triangles, AC is common. So we're going to find AC in both the cases. Let me do it and show you. First, let's take the triangle, the smaller triangle, that is the red color triangle, ABC. In triangle ABC, angle angle C is 90 degree. Okay. Now, what we are trying to do is we are trying to find the value of AC. AC is the adjacent side, isn't it? And they've given the opposite side. So obviously we have to use tan. Okay. Whenever we have got common side, we'll be making use of tan itself. Okay. Tan, what is the angle? 45 degree. Tan is opposite by adjacent. Opposite is BC. Adjacent is AC. Okay. Now tan 45 is 1. BC is 20. AC as it is. If you cross multiply, you get AC as 20 meters. Okay. So AC is 20 meters. Let's take it as equation 1. Okay. Now again, what we are going to do is we are going to take the other right angle triangle. The other right angle triangle is the green color triangle. Okay. What we are going to do is again in triangle ADC, C is 90 degree. In the green color triangle, again we are going to make use of tan itself. The angle is 60. Tan is what? Opposite by adjacent. So here opposite to the given angle, this is opposite and this is hypotenuse and this is adjacent, isn't it? So opposite by adjacent, opposite is DC, adjacent is AC. Okay. Now tan 60 is how much? Root 3. Root 3 is equal to DC. DC is how much? DC, if you observe, DC is actually this complete length, isn't it? That complete length is actually H plus 20, isn't it? H plus 20 divided by EC. Now, what you can do is, as you have already found AC, you can substitute it or find AC, then equate it. Anything is fine. Okay, what we'll do is, we will find AC and equate it. Okay, or let's substitute AC value here itself. That will be much more easier. Okay, root 3 is equal to H plus 20, or let me do what I said earlier itself. That will be very, very easy. In certain problems, you might get confused. So in both the triangles, AC is the common side, right? So in the first triangle, I have found AC. Again, in the second triangle, let me find AC. Okay. So root 3 into AC is root 3 AC. That is equal to H plus 20. Therefore, AC is equal to H plus 20 divided by root 3. So this will be your equation 2. Okay. From 1 and 2, as you can see, from 1 and 2, see, in both the cases, the LHS are same, right? You have found AC itself. So you can equate the RHS. What is the RHS? H plus 20 by root 3 is equal to 20. Send this root 3 the other side. That is, we are cross multiplying. Okay, this 20 can be written as 20 by 1. So anything multiplied by 1 is same thing. So H plus 20 into 1 is H plus 20 itself. 20 into root 3 is 20 root 3. Now we need H value. We don't need this 20. So send it the other side. So 20 root 3 minus 20. You cannot subtract 20 root 3 and 20 because one is irrational, other one is rational. What you can do here is you can take 20 as common. If you take 20 as common, what is left out? Root 3 minus 1 meters. Therefore, the height of the tower is 20 into root 3 minus 1 meters. I hope this is very clear. Simple. We have to find, always we have to check for the right angle triangle. Okay. So here we have got two right angle triangles, and in both the triangles, there is a common side. So we're going to find that common side, which is the common side AC. So in the first triangle, we found AC. Even in the second triangle, we found AC. Then on equating it, we got our required value. This is the procedure that we're going to do in most of the problems. Okay. Whenever we have two right angle triangle with common side, we're going to find that common side in both the cases using tan itself. Okay. Once we get the common side equated, you will get the answer. Okay. Let's get into the next question. A statue 1.6 meter tall stands on the top of a pedestal. Okay, there is a statue which is 1.6 meter tall, which is standing on the top of a pedestal. Pedestal is something, a base. Okay, you have base, right? You must have seen many statues where you got base. Okay, on top of it you will have a statue, isn't it? You must have seen this. This bottom part is called as a pedestal. Okay. Now, from a point on the ground, the angle of elevation of the top of the statue is 60 degree. And from the same point, the angle of elevation of the top of the pedestal is 45 degree. Find the height of the pedestal. Okay. Now, what we'll do is, let's take this. Okay. Now, let's say A, B is the pedestal. Okay. And CA is the statue. And the height of the statue is given as 1.6 meter. Okay. So here AC is the statue and AB is the pedestal. Okay. Now from a point on the ground, let's take D is the point on the ground. From this point on the ground, we are watching the top of the statue. Okay. We are watching the top of the statue. Obviously, it is angle of elevation. Okay. Let me draw it again. Now, it is obviously angle of elevation, which is 60 degree. Okay. Again, from the same point, we are watching the top of the pedestal. Top of the pedestal is what? A, right? A is the top of the pedestal. Or you can also say it as bottom of statue. Okay. Now, this point. Okay. Here, this angle is how much? It is given as 45 degree. So, same thing. The smaller one is 45, the bigger one is 60 degree. And obviously, the pedestal will be perpendicular to the ground. Okay. Again, the same thing that we are going to do. Here, we are going to find right angle triangle. Again, there are two right angle triangle. The first one is ADB. Let me draw it here. ADB is the right angle triangle. Okay. ADB is a right angle triangle. Okay. This is the smaller right angle triangle. What is the angle in the smaller right angle triangle? 45 degree. And remember, the AB will become opposite. This is hypotenuse and this is adjacent. And remember, we have to find the value of AB. That is, we have to find the height of the pedestal. Let me take the height of the pedestal as H. Okay. So H is the value of AB. This is one right angle triangle. And there is another right angle triangle, as you can very clearly see it. It is CBD, isn't it? So let me draw that also. CBD is the other right angle triangle. You got D here, B here, and C here. Okay. So here it is 90 degree and the angle is obviously 60 degree. So this will become opposite side, and this is hypotenuse, and this is adjacent. Now in between somewhere here you got A, isn't it? So here this height is CA is 1.6, and below that is H, isn't it? So this is 1.6, and below that is H. Okay. Again, the same thing. We have got two right angle triangles, and if you observe very carefully, there is a side that is common to both the right angle triangle, which is that side DB. So in both the triangles, using tan, we'll be finding DB, then we'll be equating it. Okay. So let's take the first triangle, the smaller one, that is ADB. So in triangle ADB, angle B is 90 degrees. So let's make use of tan. Tan, what is the angle in the triangle? 45. So tan 45 is opposite by adjacent. Opposite is AB, adjacent is DB. Okay. Tan 45 degrees 1, AB value is H, DB as it is. If you cross multiply, you will get the value of DB as H. DB into 1 is DB. Therefore, DB is equal to H. Okay. So this will be your equation 1. Okay. You got the value of DB using the first triangle. Let's take the other triangle, that is CDB. Again, B is 90 degree. Okay. Again, we are going to make use of tan itself. Now the angle is 60 degree. Opposite side is CB. Adjacent side is DB itself. So tan 60 is root 3. CB value, if you observe carefully, CB is this total length, right? CB is this total length, isn't it? This total length. The total length is 1.6 plus H, isn't it? 1.6 above, and below it is H. So if you add it, you get it. 1.6 plus H by DB. So let's cross multiply it. DB into root 3 is DB root 3. Or in another words, let's make it very simple. Let's swap it, okay? If you cross multiply it, what do you get? DB into root 3, DB root 3 is equal to 1.6 plus H. Then you will send this root 3 to the other side. So let me do it directly. What I'm going to do is I'm going to swap the places. That is the exchange. DB will go here. DB will go here. Root 3 will come down. Okay. Therefore, that is by cross multiplication. You get it like that. Okay. DB is equal to 1.6 plus H divided by root 3. Okay. Let me scroll a bit down. 1.6 plus H by root 3. So this is your equation 2. From 1 and 2, as you can see, from 1 and 2, both the places you have found DB itself, isn't it? So let's cross multiply it. Sorry, let's equate it. I'm sorry. In both the places we have found DB itself. Okay. So let me move this figure a bit, that side. Okay. Now from the figure, sorry, from the equation 1 and 2, LHS and LHS are same. Therefore, you can equate RHS and RHS. H is equal to 1.6 plus H divided by root 3. So cross multiply. H into root 3 is equal to 1.6 plus H. So grouping the like terms, send this H to the other side. So it becomes H root 3 minus H is equal to 1.6. Here you can take H as common. So what is left out? Root 3 minus 1 is equal to 1.6. Okay. Therefore, H is equal to 1.6 by root 3 minus 1. Now remember, we are not supposed to have irrational number in the denominator, so we must rationalize. This itself is the final answer, but since we have irrational number in the denominator, let's rationalize it. Root 3 plus 1 by root 3 plus 1. Okay, so it becomes H is equal to 1.6 into root 3 plus 1. The denominator is A plus B into A minus B. So it becomes A square minus B square. That is root 3 square minus 1 square. So root 3 square is square and root gets cancelled. We are left with 3. 1 square is 1. So 3 minus 1 is 2. So what we are left is 1 minus 6 into root 3 plus 1 divided by 2. Actually, you can divide it. 2 ones are 2.8s are. 2 8s are 16. Since there is a decimal, we have to place decimal. Therefore, the value of H is 0.8 into root 3 plus 1 meters. That's the height of the pedestal. Remember, we took the height of the pedestal as H, isn't it? So initially I had to write that. Let H be the height of the pedestal. Height of the pedestal. Initially I had to write this. Okay. Anyhow, so as you can see here, we have found the height of the pedestal. Again, we have used the same logic. We had two right angle triangles. DB was the common side. So using the first triangle, we found DB. And using the second triangle, we found DB. Equate it, you'll get the answer. Very simple, isn't it? So let's get into the next question. So the next question, the angle of elevation of top of a building from the foot of the tower is 30 degrees. Okay. Now, if you read the question carefully, the angle of elevation of top of the building from the foot of the tower. So there are two things here. One is building, the other one is tower. Okay. So let's say this is AB is the building. Okay. AB is the building. And let's say this is the tower. CD is the tower. Now we are watching the top of the building from the foot of the tower. Okay. We are watching the top of the building from foot of the tower, isn't it? So this angle, okay, the angle is with respect to the ground. Okay. This angle is found to be how much? 30 degrees. Okay. Again, and the angle of elevation of the top of the tower from the foot of the building. Foot of the building is B. B is the foot of the building. From the foot of the building, we are watching the top of the tower. Okay. So this angle of elevation is how much? 60 degrees. Okay. Remember this complete angle. Let me show it in a different color. This complete angle, building will be perpendicular to the ground, and similarly the tower will be perpendicular to the ground. Okay. Now, what is given is, if the tower is 50-meter high, find the height of the building. Okay. The height of the tower is given. CD is the tower, right? So the height of the tower is given as 50 meter. What we have to find is the height of the building. Okay. Let H be the height of the building. We have to find the value of H. So CD is tower, and here AB is building. If you write it like this, it will be easy. Okay. For the evaluator, they'll get to know which is the building and which is the tower. Okay. Again, same thing, same task that we are going to do. What we are going to do is we are going to check if there is any right angle triangle. As you can see, there is a two right angle triangle again. Okay, which are the two right angle triangles? If you observe carefully, the ABD is one right angle triangle, isn't it? ABD is one right angle triangle. ABD is one right angle triangle. Here it is B is 90 degree, and at this point D you got 30 degrees. So this becomes opposite, and the value of opposite is H, which we have to find, and this is hypotenuse, and BD becomes adjacent. Okay. The other right angle triangle is CDB, isn't it? CDB is the other right angle triangle. So you got another right angle triangle like this, CDB. Okay. So here D is 90 degree and the angle here is 60 degrees, and this value is given as 50 meter. From the figure, this will become the opposite side, and this is hypotenuse, and this is adjacent. Again, if you observe, there are two right angle triangles, and very clearly BD is the common side, isn't it? BD belongs to both the triangles. So in both the triangles, we're going to find BD and equate it. That's what we are going to do. Okay. So all these problems are of same types. Okay. In triangle, let's take the red color triangle. In triangle ABD, angle B is equal to 90 degrees. So we're going to make use of tan itself. Tan 30 degree. The angle is 30 in the red color triangle. So tan 30 is opposite by opposite by adjacent. Opposite is AB. Adjacent is BD, isn't it? So tan 30 is 1 by root 3. AB value is H. BD value, we don't know. We'll keep it as it is. Cross multiply BD into 1 is BD. H root 3 into H is H root 3. Let's take it as equation 1. So in the next step, we'll take the other triangle, that is in triangle CBD. Okay. Angle D is 90 degree now, isn't it? So in the triangle, green color triangle, what is the angle? The angle is 60 degree. So tan 60 is opposite by adjacent. Opposite is CD. Adjacent is BD. Okay. So tan 60 is root 3. That is equal to CD. Let me scroll a bit down. So CD is 50. BD as it is. So let's send BD the other side. Let's get root 3 other side. So we are swapping the place. Therefore, let me write it here. Therefore, BD will become 50 by root 3. Okay, we must rationalize. We should not have root 3 in the denominator. Let's rationalize it. So how much do we get? 50 into root 3, 50 root 3. 3 root 3 into root 3 is root 3 whole square, which becomes 3. So therefore, this is BD. Okay. So this is our equation 2. From 1 and 2, let's find it. Okay. In both the cases, we have found BD, isn't it? Therefore, we can equate it. From 1 and 2, since LHS and LHS are equal, RHS and RHS will become equal. So H root 3 is equal to 50 root 3 by 3. What we need is H. We don't need this root 3. So send it to the denominator because it's in multiplication. So it's come to the denominator. Root 3 gets cancelled. Therefore, H is equal to 50 by 3 meter. Okay. Or let's write it in the mixed fraction. If you write it in the mixed fraction, it becomes 16 2 by 3. 16 2 by 3 meters. So that's the height of the building. Okay, I hope it's very clear. What we have done is, we have found two right angle triangles and there is a common side. We found the common side in both the cases and we equated it. We got the answer. Okay, so we'll continue with the next the remaining problems in the next video. Thank you, students.